It doesn't make a difference. What matters is that the noise stops. John, I need you to turn. All right, put your knees under the desk. All right. Now, what I want to do at this particular point is go through each of these questions here. First one says, which of these is not equivalent to 1/9? Well, if I take a look at these, I get 3 to the negative 2, 3 to the negative 2, and I look over here, and what's 3 plus negative 1? Davis,
What?
if you want to keep that pen, you're going to turn the light part of it off and stop playing games.
Oh, sorry.
If you add them up, you get 3 to the negative 4. I'm sorry, it's negative 3 and negative 1, which is 3 to the negative 4. Negative exponent. So that's 1 over 3 to the 4th, which is 1 over 81. That does not equal 1/9. So therefore, it is choice C. Now, the next one says, which one of these choices, A, B, C, or D, is the correct equation for this line? And as I take a look at this, what I see is over here, I look at how much I go up by, and then I compare it to how much I go up over here. In other words, the change in y over the change in x. So in this case, I'm going up 24 and 8. So 24 divided by 8 is 3. Or I go to the last two, 6 and 2. 6 divided by 2 is 3. Any pair that you choose will reduce or simplify to 3. So that means the rate of change, or the slope, is 3. Now the y-intercept is always what 0 turns into, the output when the input is 0. So that's 4. So y equals 3x plus 4 is choice B. Any questions on that?
No.
It's an extremely important skill for both your state test and your final exam to be able to do, and it'll help you a lot next year too. Sequence of transformations was applied to a right triangle in a coordinate plane. Transformations used were translations, rotations, and dilations. Which statement about the resulting figure is true? It must be a right triangle. The lengths of the sides are proportional to the original, but not the same. Equilateral triangle, that doesn't make sense, because if you're going to do these transformations, it's the type of triangle that stays the same. Scalene, no. So then the question is, since there is a dilation in there, is the size going to change, yes or no?
No.
There is a dilation in there. What does a dilation do? Change the size. It makes it bigger or smaller. So the size must change. Which one changes size? Choice A or choice D? Choice A. Choice D says the size stays the same as the original. So it has to be choice A. First time I read it, I thought it was like yesterday, and it didn't have a dilation in there. So I was thinking it had to be D, but then I saw very quickly that it had dilations, and I avoided my Linquist daily dumb mistake. Okay, so the next one talks about a reflection over the y-axis and then a translation 4 units to the left and up 3. So if I go flip over the axis and then I go to the left and up, here's a flip over the axis to the left and up. Again, flip over the axis to the left and up. Choice C is the one that's going to do that. This guy here is a rotation. This guy here would be a flip and then down. This is a flip and then down. Only choice C is a flip and then up. Any questions?
Nope.
Okay. So this is the second in a series of quizzes. The third in a series of quizzes will occur tomorrow. All right, so, or I should say Monday. Now let's, oh, by the way, you got a test next Friday?
What?
Okay, yep. That will probably be, maybe not, maybe for you guys it won't be. For the other class, they're going to have a test too. It will be the last test of the market period. For you guys, it may or may not be the last test of the market period, to be determined. Now we have, again, an old question. Remember I just said that they like to put questions about these equations on the state assessment test? Well, here's one. X and Y. I notice the X's are going up by 1s. What are the Y's going up by? 3. So the next two boxes to fill in are 10. Then if I go up 3, I get to 13. I go up 3, I get to 16. And then it wants an equation. And I notice that my y-intercept is 4 because 0 pairs with 4. And I'm going up by 3 over 1. So it's y equals 3x plus 4, or y equals 3 over 1x plus 4. Any questions? Okay. I don't know if this is exactly the same one we did yesterday, but it sure looks like it. I plot the points 7, 2, and 3, 1. I draw my right triangle, and I notice one of the legs is 1 and one of the legs is 4. and I go with 1 squared plus 4 squared is the hypotenuse squared, and I get the square root of 17. Okay, any questions? All right. Now, let's start doing some of this work on the board. Two triangles of a triangle are 38 and 77. What's the measure of the third angle? Who thinks they got it? Josh? 65 is correct. What do the triangles of a triangle add up to, everybody? 180. So if I add up what's on there, I get 115, and 180 minus 115 is 65. And now we get to solve the equation below for x. So I've been looking through old state assessment tests the last few days, from the last 2 years, and they're actually not state assessment tests because they don't release the state assessment test, but they do release sample questions. And I've been looking through the sample questions, and I was struck by the fact that there were more equations released than I remember. So I think equations is something they're shifting to. And the really good news is that early in the year, we were great at equations. So the first thing we always ask ourselves is are the things on the same side or the opposite side? Is this the same side situation?
No.
Well, actually it is, but it's also an opposite side. When I have a same side, I want to do the same side right away. So if I have 20 x's and 5 x's, what do I have?
25.
25 x's, good. Minus 20 equals 21x plus 4. Now, what situation is it? Opposite side. Opposite side?
Opposite.
So I'm going to go minus 21x, minus 21x, die. 4x minus 20 equals 4. Add 20, die. 4x is 24, divide by 4, x is 6. Okay? So x is 6 is what it works out to be. Any questions about that?
No.
Okay, so you're getting a feel for what state questions are like. They ask you, what's the function rule? They ask you, solve this equation. They ask you, hey, what kind of transformation can this be when you know that it was a right triangle before and a right triangle after, but the size changed. So somewhere in there has to be a dilation. What we've been working on the last few days in class is this formula sheet. And what we want to be able to do, we don't have to memorize these formulas. Back in the day when I rode my pet dinosaur to school, I used to have to memorize all of these formulas. You do not need to do that. What you need to do is be able to look up the appropriate formula and use it. There are some things that you do need to understand to use. One of those things that you need to understand to use, because I don't think there's anything left in here, no. One of those things is how to do, how to do surface area. So, what I would like everybody to do, we did it yesterday, is find the surface area of this figure. I'll give you and also the volume. And the volume formula is on the sheet. So if you struggle with the volume formula, you can look it up on the sheet. I will give you maybe 2 minutes to get that done, and then we'll go over it in just that amount of time. Okay. So, we did some surface area stuff yesterday. And what we said is that each one of these figures has 6 faces, if you will, 6 sides.
Oh, yeah.
And we called those sides the what? What was the first one? Top, good.
Bottom.
And then there was the
Bottom.
bottom. No, well, top
Left.
pairs were bottom. There was left,
Right hand side.
and then there was front. Good. Now, the top piece is the piece that goes right here. And that's gonna be 14 by 3. So 14 times 3 is 42. And then it's also feet times feet, which is 42 square feet. But the top pairs up with the bottom, so that's 84 square feet. All right, so now let's switch color here, and let's do the left. The left is this piece right here. That's what by what?
3 by 5.
3 by 5, good. So 3 times 5 is 15 square feet. Again, because it's also feet times feet. And if I did x times x, that would be x squared. 5 times 5 would be 5 squared. So feet times feet is 15 squared. And then, of course, the left pairs up with the right, so this would then become 30 square feet. Now the front piece.
Ooh,
Front piece is right here,
14 by 5.
14 by 5. So this would be 14 times 5, which is 70 square feet. Front and back, which is times 2, 140 square feet. And then if I want the surface area, I then add them all up. This is 114, 254 square feet. Sound good, everybody? Good. Now, volume. You can look volume up on the sheet. And when you do that, you're given 2 forms for volume. One is the area of the base times the height. The other is length times width times height. And they both work out the same. One way to look at it is, look, this area of the base is going to be 3 times 14, which is 42. And then there's 5 such layers because the height is 5. So if I do that 42 times 5, I'm going to get the ultimate volume of it. Or I could just say that's 14 feet times 3 feet times 5 feet. And when I multiply that all out, I get 42 times 5, which is 210 feet cubed, because this time I'm doing feet times feet times feet. And that's feet to the 3rd power.
Oh,
Okay? Any question on that? All right. So what we've been doing each day is we've been looking at a figure and we've been trying to find where the formula is on the sheet and then start applying that formula. Well, here's another shape. Anybody know what this figure is called?
prism.
Cylinder, very good. Well, it's like a circular prism. Prism means it's a 3-dimensional figure, same size top and bottom, if you will. Cylinder is the one that has the circle at the top of the bottom. I like to think of it as a soup can. Now, it says find the volume of this, oh, we did the prism up above. Find the volume of a cylinder. Now, I'm going to do the work up high so you can see it better. Can you guys please look on the formula sheet and find the formula for the volume of a cylinder?
The volume.
Mhm.
Times height.
There's 2.
Okay, let's go with the
Pi.
one that's more specific. Pi
Pi squared.
r squared h, right?
Yeah.
Okay, good. So here's my cylinder, and it says that it has a diameter. Now, diameter goes all the way across, right?
Yeah.
All right, the diameter is 14. So if the diameter is 14, what's the radius going to be? 7, right? Because diameter goes all the way across. How far does the radius go? Halfway across. So this volume is going to be pi times 7 squared times the height. And what does it say the height is? 30 inches. So now, let's multiply it all out and round our answer to the nearest 10. So everybody do that. Use your calculators now, right? You want to do pi times 7 squared, which is 49, times 30, and let's see what you get. Lenny, can you shut that door, please? Right there, thank you. There you go. I just forgot to shut it before, I was in there a little bit ago. What do we get?
4,618.
4,600.
18.1.
Well, what comes after the point?
Yeah, it's one, it's
And then it is
0.14? And we said round to the nearest tenth. There's the tenths place. The 4 means stay the same, so it's 4618.1. All right, any questions about that? Hey, psst. Any questions about that? So we identify the shape, we use the formula, and we start plugging in what it is they're looking for. Okay, but there's lots of shapes. Cylinder is not the only shape. For instance, there's this one. What figure is this?
triangular.
Triangular prism. Look up the formula for triangular prism. 1/2 ABH. Okay, so volume is 1/2 ABH. So the half doesn't change. Now, ABH, this is still H, but A and B are like B and L here. It doesn't make a difference. So the height is 8, so I'm going to put 8 in place of the height. B is 16, I'll put 16 there. And the length is like A, it's the same thing. What's the length here? 25. So now on your calculator do 1/2 times 25 times 16 times 8. And let's see what you get. I think it's 1600. I think it's either 1600 or 160, one or the other. Hasta la vista, bye, con Dios, toodaloo, ta-ta, arrivederci, smile a lot, ciao, arrivederci, adios amigos, amigas, cheerio, carushus, hafiz, shalom, have fun. Yeah.